All right. So let's start with lesson 13 or Sutra 13. Um, like the other names, the Sanskrit name is pretty big, but it's pronounced as Supantya Davya Mantyam. That's the kind of the pronunciation of that, and basically it means the ultimate and twice the penultimate. Okay, so this sutra reveals a profound understanding of number patterns in perfect squares, right? The Sanskrit terms are quite descriptive. Antya refers to the ultimate or the last digit, antya, right? And upantya is the penultimate or the second to last digit, penultimate or second to last digit. And davya means twice, right? So this principle recognizes the relationship between ultimate digit, and twice the penultimate digit uh, in a number can reveal mathematical properties, particularly for finding square roots. Okay, so let's look at the Vedic insight for this particular sutra, the ultimate and twice the penultimate. So, in authentic Vedic mathematics, this sutra reveals a profound understanding of number patterns in perfect squares. So, the Sanskrit term antya refers to ultimate or the last digit, right? Upantya is the penultimate or second to last digit, and divya means twice. Okay, so this principle recognizes that the relationship between the ultimate digit and twice the penultimate digit in a number can reveal mathematical properties, particularly in finding square roots. So the ancient sages had discovered that perfect square numbers follow specific patterns in their final digits, and make a note of that. And you will see with that in the examples, allowing for rapid calculations of square roots through pattern recognition rather than the lengthy arithmetic operations. Again, that connection with how our brain works and how the modern AI works. So let's take the first example, which is the square root of 1369, right? 1369 square root. Okay. So we will go ahead and group the digit as pairs. So 13, 13, and 69. Okay. So what we do is first on the 13, right, find the square root of first group, right? So 13, and that will be closer to 3, right? So 3 times 3 is 9. Okay. So this example will demonstrate the elegant pattern recognition approach to finding square roots in Vedic mathematics. Right? So the ancient sages recognized that perfect squares ending in 9, like in this case, follow a specific patterns based on the penultimate digit. In this case, it's 6. So they discovered that when a perfect square ends in 9, okay, its square root can only end in either 3 or 7. Remember that. If it square root ends in 9, then its square root, if the number ends in 9, its square root can only end in 3 or 7. Further, they identified that the parity, the odd even status of the 10th digit, so in this case 6, whether they're odd or even number, okay, determine which of these possibilities are correct. Okay, if it's based on whether odd or even, it can be 3 or 7. Okay, and we'll see that in the example. So this systematic categorization of patterns for different ending digits show the comprehensive nature of Vedic mathematical knowledge. Okay. So we just talked about it, the step 3, right? So 69, as the second number ends in 69, right? They have square roots ending in 3 or 7. Okay. So then we apply the odd even rule like we just talked about. Digits 3 is odd and units must be 7. So if it's a 3, if the 10th digit, right, then it's an odd number, okay? And the units digit will be a 7 in the answer. If it is an even number, right, it'll be a 3. So let's look at what we went through. We know in this case, right, the ultimate digit is 9, penultimate is 6, right? So what we do is we take twice the penultimate. So in this case, it's 6, so that's a 12, okay? So again, if we look at the details of the steps, so we group the digit 1369, we take the first 13, we square root, the closest square root is 3, right? So that means the 10th digit of the solution is going to be a 3, right? So the numbers ending with 69, in this case 69, have a square root ending in either 3 or 7. Now check the 10th digit parity. 3 is an odd, right? We just talked about that 3. So apply the rule. So for the odd 10th digit with 69, right, units digit is going to be 7 from the solution, right? If you remember what we said, if it is odd and even, right? So for the odd 10th digit with 69 ending, right, units digit is going to be 7. Okay, so first square root of 13, that's 3. And because that's the 10th digit of the solution, right, then the units digit for the solution is going to be 7. So now you combine 3, which is the tens, and 7, the units. So you get 37, right? So that's a solution for square root of 1369 is going to be 37. Okay. And then again, remember that for numbers ending in 69, right? If 10th digit is odd, that means the 10th digit of what? The solution, which was the square root of 13, the units digit has to be 7, right? So that's why the answer here is 37, okay? So square root of 1369 is 37, okay? Just a synopsis, this part explains we grouped the number 1369 as 1369. We took 13, closest square root is 3, and that becomes the 10th digit. So if the 10th digit is an odd, as in this case is odd, so the units digit needs to be 7. That's as per this particular sutra. Okay. You can look at another example. In this case, we're going to do a square root of a number 2025. Okay. The same thing, we look at 25. Right. So this example demonstrates another pattern recognized by Vedic mathematics. When a perfect square ends with a 25, its square root always ends with 5. So the solution, the units will be 5. So this is a special case where there's only one possibility for the units digit, which will be 5. Unlike the previous example where we needed to consider the parity of the 10th digit, right? That was what we considered here. So the ancient sages recognized that only numbers ending in 5 produce squares ending in 25. So creating a one-on-one correspondence. So this systematic categorization of patterns for different ending digits shows the comprehensive nature of Vedic mathematical knowledge when each case was carefully analyzed and understood. Right? Just go through those steps talked about. In this case, ultimate is 5, penultimate is 2, but because ultimate is 5, the end solution will also, the units will always be 5. Okay. just to refresh step by step, right? Again, broke it up 20 and 25. In the first case, where we take 20, so the closest square root number is going to be 4, right? 4 times 4 is 16. So the 10th digit is going to be 4. Remember, we don't apply, because 10th digit is 4, we don't apply the previous rule, right? Where in that case, it would have been the units of 3. Because this is a special case where it's 25, right? The units digit will always be 5. So this is a lot easier. You take the first, closest is 4. So what's your answer? Your answer is 45. So the square root of 2025 is going to be 45. Okay? Make sense? Just take a few minutes to look at these two examples, then look at the two steps, right? And then you can see, how these patterns were considered by the ancient sages to solve mathematical complex functions, right? Which I said, this whole pattern recognition is what today, drives many of the conclusions in artificial intelligence, which is based on pattern recognition. So basically, our brain has this capacity to recognize a number, and that's what Vedic math is all about. So ancient sages, knew the power of the human brain, and that's when they talked about it, right? So if you use them, then you get better at connecting, the connections in your brain. Okay. So, in conclusion, for the sutra, right, Sopaantyadvayamantyam demonstrates the sophisticated understanding of number patterns, right, possessed by the ancient Vedic mathematicians. All they did was they recognized the power of our brain. So, by recognizing the relationship between the ultimate digit and twice the penultimate digit, they develop a system for rapidly determining square roots based on the ending digits of perfect squares. So this pattern-based approach represents a fundamentally different way of thinking about mathematics, one that emphasizes recognition of relationships and patterns rather than mechanical calculations. So the ancient sages understood that mathematics is not just about computation, but about discovering the underlying harmony and structure of numbers. So as we have seen with both examples, once you understand these patterns, finding square roots becomes a matter of recognizing rather than calculation, right? So you simulate that part of your brain to recognize the patterns and then find solutions. So this is a hallmark of an elegant efficiency that characterizes Vedic mathematics.